I feel like. So I would start this one. This one's the easiest one. It says Jason wants to earn community service hours for his high school diploma. He has already received 1 star. He plans on earning 2 stars per week. Is that the same numbers that are on your paper? Is that what it says on your paper? Yes, no, maybe? Okay, cool. He needs a total of 9 stars. So first, what is the slope in this situation? Good. Remember that 2 stars per week is going to be your slope. So your answer for that one, well, I need to calibrate my board real quick. But write that down. So right here, the 2 stars per week, I would write that down. That's my slope. And then what does it represent? It represents earning. So it's being added over and over and over again. Yeah. You're almost at spring break. You can sit in bed all day and watch TV. You're almost there. Okay, what does the y-intercept represent? Or what is the y-intercept? You have a 50-50 shot because there's 2 numbers up there that are there. What's the y-intercept? 1. Why? Yeah, so remember, initial is your y-intercept. So the 1 star, and it represents his initial amount. So initial starting value, so he started or initially started with 1 star. Easy enough, right? Now let's write the equation. What's the parent function? Y equals what? Good, mx plus b. So I know we're just going to be filling in our m and our b. What's our m here? What's our, good. So your m is your slope, which is 2, and then plus 1. Easy enough, right? Now to fill in the table, you can literally type it into table if you want it, or you know your y-intercept is when your x is 0. So I know right here that when x is 0, my y should be 1. Then what are we adding each time? What's our slope? 2. So what's 1 plus 2? 3. What's our next one going to be? 5. Our next one? Good. Next one? 9. Next one? 11. If you type that equation into the table, you would get the exact same answer. Then you're just plotting those points. So I go 0, 1, 0, 1, plot. 1, 3, plot. 2, 5, plot. Or you can start from your y-intercept and go up 2 over 1. Up 2 over 1. If I kept doing that, it would look something like that. Why wouldn't I bring the arrow down? Why wouldn't I bring it this way and go towards negative? Can I have negative weeks and negative starts? No, right? I can't give Victor negative 7 stars. That doesn't make sense. So that's why we have to start with the positives, right? And then the last one, how many stars does he have after 2 weeks? So we know he earns 2 stars per week, right? So we know our equation is y equals 2x plus 1. We already came up with that. And so if it's 2 stars per week, that means my x stands for weeks. So what am I going to be plugging in for x? 2. So instead of x, I'm going to plug in 2. And what is 2 times 2? 4 plus 1. 4 plus 1. 5. So after 2 weeks, he'll have 5 stars. I can also look right here and see on my table after 2 weeks, he'll have 5 stars. How long will it take for him to earn his community service star? So he needs, does it say 9 on your paper? 9, right? Okay. So he'll need 9 stars in order to get a community service award. So I know if X is weak, Y needs my total stars. So I can plug in 9 for Y and solve for X. Y'all can literally look up here and go, okay, when is he going to have 9 stars? After 4 weeks. If you do it this way, or it doesn't show up on the table, you just solve for X. So I subtract 1 from both sides, I get 8 equals 2X. Then how do I get X by itself? Good. Divided by 2. What do you get? Yeah. What does it say?
Pardon the interruption. Do you have Quran?
No, I do not.
Okay, thank you.
No problem. It is 9 stars though, right? Yeah,
For a badge.
for his badge. Either way, yeah, the writing might be different, but it still will be 4. Yeah, the wording was just different. It's probably what it's going to look like. Does everyone get how to do this? Easy enough, right? Okay, so I would probably choose that as one of your 2. Now let's go to the next one. So the next one's going to be like, first you're going to put that into table. Automatically, go put that into table.
Type it into table. Type your function into table. Do you have a table function? Let's see, Claudia, have you got the points? Can you help me fill them in? What is it? Awesome. Did everybody else get that for their table? No? After that, we're just plotting points. So the first one we have is -5, -5, over 5, then down 5. Then we have -4, 0. -3, 3. This is really hard to do up close. So your dot should look something like that. Are we all okay on plotting points? Anybody have any questions about plotting points? Awesome. So then you just connect your dots. Okay, great. Who can tell me the coordinates of the roots? Perfect. How did you know that that was a root? Comma 0. What's the other vocab word for roots? What are some of the words for it? Zeros. Solutions. And x-intercept. So we're looking for our x-intercept. So there's 1. What's my other x-intercept? 0, 0.
For brain bug, who can tell me the vocabulary word for 0, 0, raising your hand? Come on.
So what was the coordinate
of the y-intercept be? Yep, it's also 0, 0. Oh y, can I remember my y-intercept? So you're looking where it's 0, something. Happens to be the same one. If we're talking about the range, am I looking at my x values or my y values? Your y values. So what's the lowest y value that your graph would go to? Yeah, I heard it, negative infinity. Because of those arrows, that means that it goes down forever and ever and ever. If the arrows were at the top, what would that be? Positive infinity. So we always go from the bottom up. So what's the highest y value that our graph is? 4. Do I use a bracket or a parentheses here? Bracket. Because it includes that number 4. Which section is the positive section, the red or the green? The red. Between what two x values is it red? -4 and 0. Between those two x values is where it's positive. If you forget how to write it in interval notation, then you can write it between where x equals 4 and where x equals 0. You could write it before x equals 4 if it's on the other side. If you don't remember how to use interval notation on an open-ended test like this, go ahead and use your words to try to describe what's happening, and you might be able to get partial credit for it. That's better than leaving it blank. Okay, what sort of transformations can be found? I heard them all. Awesome. So we had a reflection. What part of this made the reflection? What part of the formula? That negative. That's the reflection over the x-axis. And then left how many? How did you know that it was to the left? Because it's plus, or from looking at the graph, you can see that the graph moved from the origin to the left. And then, what was the last one? And where did we find the up 4? Awesome. From the vertex or from the end of the equation where it says plus 4. So what equation would represent the axis of symmetry? X equals -2. How did you get that, Corey? It's the line that splits it down the middle. I always remember to do the line that splits it down the middle because it tells me what number. See how I cross out the number -2? I know that's the number that I need to use. On your test the other day, some people were saying x equals 4, but that's not the x equals 4. X equals 4 is everything. So make sure you're checking that your answer makes sense. And it's always x equals for the axis of symmetry. You know, we love how Miss Kay said it's so funny to help us remember. So what's the coordinate of the vertex? -2, 4. You can look for the vertex sandwich in your table, or the point where the bounce is, or the top or bottom of your graph, whichever way helps you the best, but you have all those methods now that you've got them. So identify the interval where it's decreasing. it's not from -6 to 0. Which side of the graph is decreasing? The left or the right? The right side. So for the right side, where does it start decreasing? At what x value? -2. So it starts decreasing right here. So this x value is -2. And then it keeps decreasing forever and ever and ever, right? Not negative infinity. It does go down forever and ever, which would be negative infinity. But this side, the right side of your graph, is positive numbers, right? So it would be positive. Remember, we're talking about x values. Whenever you see interval, you're talking about x values. Now, some of you might like this one because it's super fresh in your head because we just did this unit. But I know that decreasing and positive sometimes trips us up. But if you feel really confident about it, especially since you're going to be taking this next period, you don't have a lot of time to forget it. You can start this one or you can do the next one. Okay, so the last one is going to be systems. And so probably not a lot of you will be doing this one, but you still do need to remember it. We haven't touched it in a while. So what we're going to do is I'm going to be doing the elimination method, and Ms. Thompson will do the substitution method. You only have to pick one of them. And so this might look a little bit different than your page. So for example, see how B, like S and B. So maybe yours says BS. So cross it out, put S and B, so it's in order. And it says Donald wants to sell products for his business. During hour 1 of the business, he sold 9 sodas, 3 burgers, and got 21 bucks. The business took in $18 the second hour by selling 6 sodas and 3 burgers. Find the price of each soda and each burger. So first I need to define my variables. What does S mean? The price of a soda, right? Because we're trying to figure out the price of a soda. So what does that mean B means? Good. Price of a burger. So first I define it. You get points just for doing that. Next I'm writing my systems down. So I see that there's 2 situations. There's hour 1 and then there's hour 2. So in hour 1, he sold 9 sodas. So 9, and what's the letter that goes after it? S, right? 9 sodas plus 3 burgers. And how much money did he get? 21 bucks, right? So we just write it. It's one situation, then the next. Even if you're not going to use this one, still write it down because this is going to be like a lot of your milestone is systems, which kind of is a little stinky because we don't really go back to it that much. But it is most of your open-ended and problems like that are going to be these systems. The second one is the business took in $18 for 6 sodas and 3 burgers. So those are my 2 equations. I get a point just for doing that, just for writing the equations. Then on your test, you're going to have to use elimination or substitution. I'm going to use elimination. It's actually easier to me because I can see it's going to be pretty easy to get a number, same number, different sign, so that I can eliminate a variable. So first, what do you think is going to be easier to eliminate and get the same number, different signs, the S's or the B's? The B's, right? It's already 3. I just need to make one of them negative. So I know I'm going to be playing with the B, and I'll make the top one plus 3B and the bottom one minus 3B. What do I need to multiply to the bottom one to make it from positive to negative? -1, right? And so remember to share the love. -1 needs to be multiplied to every single one. So -1 times 6s, I end up getting -6s minus 3b. And then what's -1 times 18? -18. Just changes the signs. Do I need to do anything to that top one to get it to b plus 3b? Or is it already like that?
Do I need to multiply anything to get it to be positive 3b? No, so I'm just gonna rewrite that problem. 9s plus 3b equals 21. Now, what do I do between these two equations to eliminate the variables? Do I subtract, add, multiply? Add. Perfect. So I'm always adding them. When I do that, 9 plus negative 6 is what number? What's 9 minus 6? Good, I get 3s. What's 3 minus 3? What happens to my b's? They cancel, they eliminate. And then 21 plus negative 18 is 3. Cool. Then how do I get s by itself? Divide by 3, and you get s equals 1. That means that a soda costs how much money? $1. So I'm going to go down here and go, oh yeah, that means my soda is going to cost $1. To get my burger, I plug it in, right? It doesn't matter which one I use. I'm going to use the top one. But now all I do is instead of s, I'm going to plug in what s is. So I'm trying to find how much a burger is. And I know that we just found that s is 1. So instead of s, I'm going to put in 1 for that original equation. Doesn't matter which equation you use. No. Now I just solve. What's 9 times 1? 9 plus 3b equals 21. How do you get b by itself? What do you have to do with that 9? Good. Subtract 9 on both sides. And you get 3b equals 12. Then what do? And what do you get b equals? Good. So that means a burger costs how much money? $4. To check my work, just because it's a test too, if I want to check my work, what do I do with those two numbers? I plug it in. So that's how you do it, elimination. That's probably the easiest method, but I know a lot of people, especially in this class, like to turn it around to be substitution. I am going to erase this. So does anyone still need this? Because Ms. Thompson's going to do the substitution part. No? Yes? Maybe? Okay. So.
Okay, so let's see. Allison, do you want to solve the top equation or the bottom equation? The top one. Okay. I'm going to go ahead and pick for us just because I know which one's going to be easier. I'm going to solve for b. You can solve for s, and you'll still come up with the same answer. It's just you're going to get your fractions. And I don't think we want to do fractions. Does anybody want to see us add it? Okay, so we're going to solve the top one for b. How do I get b by itself in the top one? What do I need to do first? I think I heard it. Not multiply. Who do we have to move first? Yeah, the 9s. So to move it, I'm going to subtract 9s from both sides.
So this is like going from like standard to slope intercept. Kamari, why couldn't I combine that? They're not like terms. A lot of people in this class start combining things. Remember, you just rewrite it.
Also, as someone who had really bad handwriting and still has really bad handwriting, one of the problems that I've seen before is we were unintentionally rude. S can sometimes look like a 5. Make sure that you're able to distinguish your S from your 5. It's happened to a lot of people before, so I just wanted to point that out. Okay, how do I get b by itself now? How do I separate the 3 from the b? Divide. So we're going to divide everything by 3. Negative 9 divided by 3 is negative 3. And then 21 divided by 3 is 7. Are we all with me so far? So now that we have what this variable is equal to, we're going to plug it into the other equation. And you have to make sure you plug it into the other equation. So we have 6s plus 3b, and we know what our b is equal to. It's equal to negative 3s plus 7 equals 18. Okay, so now we're going to distribute. What's 3 times negative 3? Negative 9, so we'll have negative 9s. What's 3 times 7? 21. What's my next step? Combine like terms. So let's combine the 6s minus 9s. What does that leave me with? Negative 3s. Now what? Subtract 21. Last step. 5.
You're gonna see that this is a lot more writing and work than elimination. But if it gets you the answer,
You still got the same answer. The price of the soda is $1. And then you go back to this step right here that you did on this side. But we can totally rewrite it if you want to. Do you want to plug it into the top equation or the bottom equation, Damon? Which one do you want to plug it into? Top or bottom? Doesn't matter. Bottom. Okay. So we have 6, and then instead of our s, we know that it's equal to 1.
and on your performance final, you only have to pick one method. We're just doing this because a lot of you guys in this class particularly like using substitution no matter what.
Now what do? Should be old hat. We have it on the picture already. Subtract 6 from both sides. Divide by 3. Oh my gosh, the price is still the same. It's whichever one you feel more comfortable with, depending on the problem. Like I said, if you had solved for soda, you still would have gotten the same answer. It just would have had fractions.